All right, so now we're going to talk about transformations with the logarithmic function. And again, you still have your a, h, and k. It's just your parent function is switching here, okay? So a parent function here is going to be log base b of x, where the base, again, is just any real number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? Going to infinity, all right? So they all mean the same thing still. So h is still your horizontal movement. That's still left to right, and it's still opposite. Okay, so a positive h means you're going to go to the left, and a negative h means you're going to go to the right. Okay, and then if a is negative, that means you're going to have an x-axis reflect. Okay. Then remember, we're done after that negative's gone, and then we continue to your stretch or compress. This is going to be a vertical stretch. This is going to be a vertical compression. Okay, so it's really the same thing as when we did exponentials. Okay, k is that last number, which is going to be your up and down. Okay, because it's the vertical movements. So a positive k means up, and a negative k means down. Okay, so we're going to do examples just like we did with exponentials. Okay, so again, highlight your parent function. My parent function here is log base 2 of x. So this right here is my parent function. Anything added to that is a transformation. Okay, so a minus 3 on the inside's h, which is left and right. So that's my h value, which means I went to the right 3. Okay, again here, this is my parent function. Now that 3 is on the outside, so that is your k value, and that means I went down 3. All right, this one, same thing, highlight your parent function. Okay, now look here, I have a negative out front. That negative means x-axis reflect. There's no a value, so I keep on trucking, okay? And then on the inside is another minus 3, which is your h value, which means I go to the right 3, okay? All right, let's keep going. So we're changing parent functions. We've got a log base 3 of x. So the log base 3 of x is going to be your parent function, so we're going to highlight it because that's not a transformation, okay? So here we do have an a value, okay? The a value here is a 2. That's greater than 1. That's our a value, okay? So that means we have a vertical stretch by 2. Then we keep going. A minus 3 on the inside, that is your h value. So that means we're going to go to the right 3. All right, let's move on. There's no a or a negative, so let's keep going. We have a positive h value. That means we're going to go to the left 4. And then a minus 3 on the end is your k value, which means we went down 3. All right, keep going. Now, if you look over here, I have a negative and an a value. So that's 2 separate transformations. So this negative means x-axis reflect, okay? And then that a means something totally different. That a is greater than 1, so it's a vertical stretch by 2. Okay, see how they're different transformations? You got to keep the negative and the number different. And then I have a minus 4, which means I went down 3. All right, so 2 more examples, okay? So 2 more examples. Again, my parent function is log x. If there's no base, it's an understood 10, okay? But we don't have to worry about that right now. So I'm highlighting my parent function. Now let's name those transformations. So there's no negative, but there is an a value. The a value is less than 1, so it's a vertical compression by 1/3, okay? Then inside is a minus 3, which is your h value. That's going to be right 3. All right, and then you have your k value at the end, which means we went up 2. All right, so last problem, and then we're going to look at the asymptote, and then we'll be done, okay? So here you have a negative. A negative means something separate. So this negative means you have an x-axis reflect, okay? And then that 5 means you have a vertical stretch by 5. And then we have the +2, which means to the left, to the left, to the left. Keep wanting to sing that song every time I say it. Then +3 is going to be up 3. Now, I want to do the same thing I did with exponential with the equation, okay? So we're going to get me a new page first. Let's see here. Enter. Oh! I thought I had a page ready. Here we go. All right, so we're just going to enter and make that stuff go away. All right, so you have the equation y equals log. You have your a, okay? A log with a base b of x. Now, we have the x minus h plus k. So in the exponential, the k was your asymptote. So in a log function, your h is your asymptote. So your asymptote is x equals opposite h, okay? So let's go up and find the asymptote for all these. So again, if you don't have an h, the asymptote is 0, okay? So remember that it's x equals because it's with the x value. So it's x equals opposite h. So here it's going to be x equals 3, okay, opposite h. There's no h, so x equals 0. My bad, guys. Over here, my h is -3, so it's going to be x equals +3, because opposite h. Here I have another -3, so x equals 3. Here my h is +4, so x will equal -4. I have no h here, so x equals 0. My h here is -3, so x equals +3. And my h here is 2, so x equals -2. All right, so you have an assignment, and that's it for me. Let me know if you have any questions.